Okay, so today in this video we're going to look at rational exponents, which is covered in section 7.4 of your book. Some prerequisite knowledge before you watch. Make sure you view my video on simplifying radical expressions. And a couple other key concepts we have already learned this year is if we have a radical expression, which we already know what a radical is, it can be rewritten as a rational expression. Okay, one example of this would be if we had the square root of 25, which we all know is 5. Well, the square root of 25 is the same thing as 25 to the 1/2 power. Okay, so when you see the word rational, it means there's some sort of fraction in the problem. In this case, it's in your exponent. Okay, the cube root of 27, we've also learned that a cube root is the same thing as the 1/3 power. So if you type the cube root of 27 or 27 to the 1/3 power in your calculator, you're going to get 3 both times. Okay, the same thing can be applied to the 4th root is the same thing as the 1/4 power, the 5th root is the same thing as the 1/5 power, etc. Okay, so the general rule is if we have the nth root of x to the m power, it is the same as x to the m over n power. Okay, one little hint that I like to do, I like to write my exponent diagonally like this. That way the m still looks like it belongs as an exponent to the x, kind of like it was right here. Okay? Another thing to keep in mind is this right here is the same thing as this. All you're doing in this process, at the first one, you're raising x to the exponent, then taking the root. Here, you're taking the root, then doing the exponent second. The reason we can do these steps either way is because taking a root and raising an exponent is the same step in the order of operations. And we're going to see an example later where it might benefit us to do it the way I wrote in blue, or it might benefit us to do it the way that is written in the typed. Okay, so we're going to take a minute and look at a couple examples. Okay, so these first two examples, we're going to take each of these radicals and rewrite them as rational exponents. Okay, so the first one, we know a is going to be our base. And once again, I always like to write my fraction diagonally. Well, 3 is the exponent that goes to a. And our index, well, remember, square root from our previous video doesn't show the index, which we know there's an assumed 2 there. So the square root of a cubed is the same thing as a to the 3/2 power. Okay? The second one, now this time I tried to write it the different way. I put the parentheses and put the squared at the end. But remember, the squared is still the exponent that ends up going to b. So we can rewrite this as b to the 2/5 power. So your exponent to your base is always in the numerator of your fraction. Your index is always in the denominator. Okay? And one, like I said, another easy way to think about it, if you remember that the square root is the same thing as the 1/2 power, there's your exponent of 1, there's your index of 2. So if you ever forget which one goes in the numerator, which goes in the denominator, always think about the square root in relationship to 1/2. We can also work the other way. I can give you a rational exponent and we can rewrite it as a radical expression. So if we wanted to take x to the 3/5 power, okay, well we know 3 is our exponent because it's in the numerator. So we know we're going to have x cubed. 5 is going to be our index. So we're going to have the 5th root of x cubed. Or we could have the 5th root of x all being cubed. Like I said, these are comparable answers. Either one is acceptable. Okay, now down here you'll notice, well, we have a decimal. Well, we just have to take that decimal and transition it into a fraction. So 2.5 is the same thing as 5 over 2. And then we can rewrite this as 5 is our exponent, 2 is our index, and remember the 2 does not get written down, so we have the square root of y to the 5th, or the square root of y to the 5th. Once again, same thing. Okay, so let's take a look at how we can actually simplify using this. Okay, so right now we have negative 32 to the 3/5 power. Okay, so if I don't have a calculator and I can't just type this in, it might be a little better visually to rewrite it as a radical. Okay, so I know my base is negative 32. I know 3 is my exponent. 5 is my index. Now this is the situation where possibly this might not have been the best way to write this down. Because honestly, I don't know what negative 32 cubed is off the top of my head. So if I get a calculator out, we can go ahead and work that out. But then you're going to end up having a really, really large number and then having to take the 5th root of that number. So this is the kind of problem where it might be better to rewrite it the other way, where we're taking the root first and then raising the exponent last. Now, we haven't really memorized 5th roots this year, but we know our cube roots and our 4th roots. Well, the 5th root of negative 32 is just negative 2. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 will give you negative 32. And we know if we cube negative 2, that will give us an answer of 8. Excuse me, negative 8. Because when you cube a negative, it is still negative. So, once again, I told you earlier, these are the same thing, but we found out the writing it this way helped us simplify in our heads instead of using a calculator. Okay, so what about 4 to the negative 1.5 power? Okay, so negative 1.5 is a decimal, so we can rewrite that as a fraction. So we know 1.5 is the same thing as 3 halves. Okay, now some of you guys are probably saying, why do we have a negative exponent here? Okay, so remember, our rules of negative exponents is we take the reciprocal of our base, which would be 1/4, and then you can take your exponent and then make it positive. Okay? Or the same thing as taking the 4 to the denominator and raising 4 to the 3 halves power as well. Okay? So in this case, if we want to rewrite this as a radical, we could write the whole entire 1/4. The whole thing is getting cubed, and we're taking the square root of it. Okay, so either one of these is acceptable. So I'm looking at it right now, and I'm thinking the second way I wrote is probably going to be a little bit easier. So we know the square root of 1 is still 1. The square root of 4 is 2. So the square root of 1/4 is a half. And when we cube a half, we get an 1/8. Okay, if you did it the other way, if I would have cubed 1, it's still 1. If I would have cubed 4, it would have given me 64. But then when I take the square root of 1/64, I still get an answer of 1/8. So it seems like in this problem, it didn't matter which way you solved it because the math was pretty easy either way. All right, last example. And I just put something up there to kind of show you the benefit of rational exponents in comparison to radicals. A problem like this, if you were asked to simplify root 8 times root 8 cubed, okay? If we wanted to do this with radicals, okay, there's a couple ways you could go about this. One, we know that the square root of 8 is 2 root 2. Here, we know that 8 cubed, well, that's one of our bigger numbers that we should have memorized, okay? So some of you guys might want to do that work separately, or we know that this is the same thing as this. And if I simplify root 8 down to 2 root 2, I can then cube 2 root 2, which might be a little bit easier. So that's 2 times 2 times 2, which we know gives us 8. Root 2 times root 2 times root 2. 2 times 2 times 2 is still going to end up giving us the square root of 8. 2 times 8 is 16. Root 2 times root 8 is root 16. Excuse me, root 16. And root 16 is 4. 16 times 4 gives you 64. Now, if you didn't follow me there, I know I just did a whole bunch of work, and I did a lot of it in my head, and you're probably saying, that's a lot of work for such a kind of simple problem. Well, here's where rational exponents really try to make this a little bit easier. So I'm going to go ahead and take this off, and I'm going to redo this with rational exponents. So we know the square root is the same thing as the 1/2 power. This one would end up being 8 to the, well, my exponent's 3, my index is 2. If you remember from Algebra 1, when you multiply like bases, we add the exponents together. So the base stays the same. 1/2 plus 3/2 is 4/2. And we know that 4/2 is just 2. 8 squared is 64. So notice, I got the same answer doing a lot less work, and I really probably didn't even need to show all this work right here. Okay, so that's one benefit to rational exponents is it makes a lot of problems easier when you're multiplying radicals together.